So let us now discuss a bit about hash functions, and more specifically, we will consider two particular examples of hash functions. Okay, so we have seen basics of hash functions, basic idea of hash functions in the lecture. Now we will see two concrete examples of hash functions, and we will write down the algorithms for computing those hash functions. Okay, and there is something called a hash table, which is associated to a hash function, and I'll just uh, elaborate on that as well today. Okay, so this is about two examples of hash functions. Okay, two important examples of hash functions. So what is the standing assumption here? So if you remember, we had to use a hash function to map elements from an array to a smaller set of indices. And in those indices, you had linked lists or sometimes queues or sometimes stacks so that repeated values are allowed. Okay. And we have already seen a way to insert elements in linked list now. So that is not really a problem. Okay. So what is it that we are going to try to do now? So for this particular example, we need a very, very simple version of linked list. Okay, very simple version of linked list. So let me go back to linked list insert function that we just saw. So if you see here, this is where we were inserting a value a along the up pointer of vertex I with down arrow pointer pointing to this. Okay, but this is a very general concept of linked list. What we really need is a much simpler version of linked list. Okay, so let us do that first. So what is the standing assumption? So we are given an array A. So let me write it as 1 to n of elements, where n could be really large. Right? That is the first thing. Now hashing, when we consider hash values, those are supposed to be much smaller. So we are considering another integer, fix a positive integer m, which is usually much smaller than n. Okay, that's why you're going to hash. You have n elements in the array A, and you're supposed to hash these n elements into m buckets, right? That's the idea of hash function, correct? But now how do we do this? So for hashing, so this is usually how you say it. Hashing means to construct a hash function. Okay, so for hashing, what really do we consider? We have another array, a smaller array, h. Okay, because this is for the hash pointers, 1 to m. Okay, there are only m indices. So what is the nice thing about this? Where each hi, what is each hi? Each hi is a pointer to a link to the head of a linked list. Okay, or you could consider it as Q. Okay, now what we really write down here is somewhere in between a stack and a queue. Okay, it's more like a list. It will not look like a queue, it will not look like a stack exactly, very similar. So rather it's best to think of it as a list. That's all. Okay, right. So what is this list? So before I go ahead, this linked list will always be denoted as L of I. Okay, I'm giving it curly brackets because this is the name. L of I itself is the full name of this thing. Okay, it's not a value, it's not an argument that you pass. It's a full name. Okay, HFI is the key value of the array at the ith position, but HFI is going to be the head of this. So this is going to be, in other words, Li dot head is going to be equal to HFI. Okay, it's going to save the head value. Is that okay? So the rest of the thing is actually very easy. So let us just consider first the algorithm for inserting an element into a linked list. Okay, into this linked list of this kind. Okay, how do we do that? Let me copy paste the code from the previous thing that we just saw. Okay, and then I'll say what changes are there. All right. So there is a list, but we are not really concerned with inserting it at some particular vertex. No, we are always going to insert it at the end. Always the index is going to be L dot length plus one. Okay. So this is gone. All right. There will be an up pointer and there will be a down pointer. But that's all. There are no multiple down pointers. Okay. And then just a value A. All right. Now what changes are going to be there? So obviously start and stop. And whatever is the length of L, right? You are going to free up one more space, a new space, that is L dot length plus one. That will be the new value that you insert key, right? But now, here's the thing. This is going to be the last element of, okay? This is going to be the last element in that list, the new element that you add. L dot length plus one indexed element is the last element. So its down pointer is actually going to be empty. There's not going to be anything after that. Okay, that's one thing. Secondly, the up pointer of the new element is going to point to the previous element. Okay, it's going to point to the previous element. So the index is just L dot length. Is that okay? All right, just L dot length because the previous location. That's going to be the up pointer. What else? Well, at the L dot length, the previous location, its down pointer was empty because that was the end. So now we have to change its down pointer. So L at L dot length plus one, its down pointer is going to be L dot length, sorry, not plus one. Okay, and we have inserted this, and now there is no more checking or anything of that kind. That's it, because this is growing like a cube, more or less like a cube. Okay, it's going to be linear. Okay, so that's it. That's all that we have to do. Okay, that completes this. All right. Okay, so now how do we hash an array into this? So this is what we will do. So hashing array A, right? How do we hash this? Okay, so we already have the array A, we have this array H, okay, and we have created L of I for each I from 1 to n. Okay, that is the assumption. And now comes the algorithm. So let's call it hash. Then what is it? A H. Well, A H and all of these lists. L1, L N. There are these many, right? All right. So now once again, start, stop. Okay, this is what we have. What are we going to do? So this is the first thing. Okay, so hashing array, and what are we going to use? We are going to use what is called the division method. Okay, by the division method. So let me not just call it hash, let me call it div hash. Okay, hashing by the division method. Okay. What do we do now? We have to now insert all the elements, right? So for I, or let's say j equal to 1 to n, right? And now these elements, aj is your element, it has to go into some hi somewhere. Is that correct? All right. So where will it go? This is what we do. So let me initialize a small variable and let's call it hash var equal to j mod m. Okay. What is mod m? So let me write down a note here so that it's clear to you. Note that a mod b by a mod b is the remainder obtained after dividing a by b. Okay, you apply the division algorithm and then you get a remainder, right? That is a mod b. Okay, so hash val is j mod m. Note that j mod m is going to be between 0 and m minus 1. Is that correct? 0 and m minus 1. Right? So in order to get the correct index, we also have to do plus 1. That's all. So then what do we set? We will set the above algorithm. Insert okay. What is this? Insert into L of hash val plus 1 plus 0 to m minus 1. We are making a choice between 1 to n. Okay. So hash val is okay. And what's the up? Well, up is up, down is down. The value is ag. Up is up, down is down. Value is ag. Okay, that's it. Just compute the hash value and into that bucket, into that list, you put the key at ag. You put the value ag. The rest of the things get sorted out on their own, because we have already written down this algorithm. Okay, and that's it. That is the end of the division hash. The third, a second variant of this, another version of this thing, which is by the multiplication method. Okay, multiplication method. It is not very different. very much similar. So hashing array A by multiplication method. Here, what do? We will fix a positive real number, 0 less than, let's call it something, C less than 1. Okay. We have to fix this. We have to fix this. Okay. And then that is also passed on as a parameter to the algorithm. Is it okay? And then what is this? Well, this is not too different. So now what we consider is, let's call it multi-hash versus hashing using multiplication method. The parameters are A, H, of course you have L1 to Lm as they were. You also have C. Is that okay? You also have C. All right. And what does this algorithm do? Start. Here's the thing. Not too different, but slight difference. For j equal to 1 to n, because n is the length of A. So rather than writing n, let me write A dot length so that it is clear. J equal to 1 to A dot length. The hash val is calculated differently. Okay? Hash val now is equal to, so you know floor function, right? Floor function of any positive real number is this largest integer lying below that number. Okay, so we will take the floor function of something. What is that? Floor function of m times. So I hope you understand star. Star means multiplication. Okay, star means multiplication. M times, and now this is the interesting thing. K times Aj minus floor of K times Aj. Is that okay? Right. What are we really doing here? So I'll leave some space so that it becomes clear to see what's going on. What is this? So you compute this quantity K into Aj minus floor of K into Aj. Sorry. C. C is a positive real number, right? So this is not an integer, it's some number, right? So you take the floor. Okay. So this minus this is essentially the fractional part of that number. Okay. Every real number is an integer plus a fraction, plus a fraction that is less than 1. This is that fraction. Okay. So C times Aj minus floor of C times Aj, compute that. That number multiplied with m. M is the hash function that you have. The size of the hash function. Okay. There are m buckets. M times that value. That is again a real number. Take the floor of that. That's the hash function, hash value. Okay. So instead of dividing, we have sort of resorted to multiplying, but that's all. Instead of dividing, you multiply by a real number less than 1. That essentially works more or less like division. Okay, you're getting smaller numbers. That is the idea. Okay. So that is the hash value, and then the rest of it is the same. So just insert exactly the same command as before. L of hash value plus 1, comma, up, down, page. Okay, so just be careful about this quantity. This is another way of getting smaller numbers. You could either divide or you can multiply by numbers less than 1. That's the basic idea. Okay, and that is it. This gives me another function but this is now via multiplication method. So it's called multi-hash. Is that okay? So these were the two examples of hash functions that I wanted to show to you. And now what do we do? So let's start hashing. So let me give you a small exercise. Take the array A equal to, so let's give some numbers. Okay, this is some array of some particular size. And let m equal to 4. Okay, so semicolon is just a sentence. Let m equal to 4. What else do we need? We need c to be equal to, let's say, 0.6. Or take half, 0.5. Okay, 0.5. That's equal to 1. Is that all right? Question is, let me just write it this way. Simulate, run the two hash function algorithms by hand. Okay, so manually. Okay. So how do you write down the list? So the list, I don't want you to write down every single detail. Just draw the algorithm and see what you get. Okay. Just as we were drawing the list, right? I will draw an arrow and then I'll do the whole thing on the board. Just do that much. That is what I mean manually. Okay. Just draw the diagram so that you get an idea of what this hash function is doing. Okay. We'll see more examples in the tutorial in this, but do this much for this example. Okay. Do both of them, the division one as well as the multiplication. Is that okay? Do both. So that was a small note about hash functions. We'll stop here now.